We'll be discussing paging operation, but there is something we need to discuss before we uh, explain the actual paging, and that is a requirement of splitting the geographical area, the area of coverage, into small parts, and each of these parts are called tracking area. Uh, Similar concept has always been there in 2G or 3G. Actually, you need that, otherwise you cannot solve the solve some. I mean, resolve something. Okay, we'll be talking about that today, and so the title is tracking area. In older technologies, 2G or 3G, there is, as I said, that you had the concept, but then it was called location area when it was considered for CS operation, circuit switching operation, and it was called routing area when you considered packet switching operation. Now, this slide explains why you need this kind of areas. These areas are some uh, geographical area. I mean, you split the whole area of coverage into different location areas. All these location areas are numbered, okay, and these numbers were called location area code (LSC). So every location area had some LSC. Okay, and each location area consists of a number of cells, good number of cells. How many? It depends. Okay, it can be 20, 30, 40. It depends on the radio planner, but you have a composition of a good number of cells for each of the location areas. Well, why you need that? When you are in idle state and the network needs to talk to you, uh, you had, I mean, in idle state you had really no communication. Okay, uh, then the way the network initiates this communication is the use of paging. Okay, this point, you can hear me, right, guys?
Yes, sir.
Okay, so let us write something. Give me a second. In idle state, the in LTE it is called RC idle. Okay, but in general, you always had the idle and connected states. Okay, in 2G or 3G. In 3G, there are actually 5 different states, but one of them is idle. In 2G, there are two idles. Now, in idle state, the EV and I mean there is no data transfer, so there is no resource allocation, and the position of EV can change. You may roam around. You may be traveling through the whole city. Maybe you are also changing the district, but you're not making any call. Okay. So in that case, if you want to update your location whenever you change yourself, then you actually need to talk to this network to update your position, right? So every time you move to a different cell, okay, if you want that the network knows your position, I mean which cell you are in, then you have to communicate with the network. So that requires some consumption of radio resources. Without radio resources, there is no way you can communicate. But you're not making any calls, so why you update the network? What is the necessity? Why you uh, consume these resources? There is no use of it. Okay, there is. I mean, you're not making any call. There is no real data session. So why you consume the radio resource? It doesn't make any sense. So what is done in the case of idle state? The UV does not uh, notify which cell it is in, or which cell it is in, because such notification would consume radio resources. Maybe instead of notify, I write down update. It may be changing its self, but it doesn't update. Um, so the EV does not know the network. The network does not know the cell that the EV belongs to. Oh man, with this writing pad, it is even. Okay, now the problem is what problem. So it's advantageous clearly, but a problem we face that when you want to, okay, now see from idle state, if there is a requirement of initiation of data transfer, and that requirement can be from any side. If you need to uh, if you want to initiate the data transfer, then please I mean pay your attention today. Okay, so basic concepts I'm explaining all these things, whatever we have been discussing are really what is happening with your phone. Okay, things are working this way currently. uh, so if you want to initiate, okay, data transfer in uplink, initiation of data transfer in uplink, okay, then the procedure is random access, which we'll discuss in detail later. You send some bits to the network, and the network responds to you, okay, what do you want? That's how you start communicating with the network, and you uh, subsequently you tell the network that I need to send some data. Okay, so the network allocates resources. That's how it works. And if then there is the initiation of data transfer requirement in downlink, there can be few other purposes too. We'll see. Okay, then the network knows that okay, it has got some data which it needs to forward to the UE. So the procedure can be paging. Okay. And this actually, uh, I mean, we can consider it some data session. Okay, by data transfer, I mean that a data session you want to initiate. Okay, say video call, voice call, or some FTP transfer, whatever. Okay, so from idle state, if there is a requirement from for downlink or for uplink, okay, then you have this random access or paging procedure. But for paging, the network then needs to notify you that a data transfer session should be initiated. Now, how the network can do that? The network does not know which cell you are in. Okay, if it doesn't know, then all the base stations throughout the whole country has to send some messages that uh, this person who should, I mean, should respond. Okay, I'm looking for this person. Okay. Because I mean, the cell wise location is not known. So all the cells has to send some message that the network is looking for this particular person, and that will again be a consumption of great amount of resources. So on one hand, if you don't update the network with your cell wise location, uh, then you can save resources here. Okay, resources for update operation that you can save. But on the other hand, when the network wants to page you, you actually need, I mean, if the network knew your cell, then that particular cell could only broadcast the message that I'm looking for this person. But now all the cells in the country has to notify, right? So the paging uh, operation in this case uh, can again be burdensome for the resources. So what can be the solution? I mean, both are sort of uh, extreme wastage. So the solution, or the what the practice is something in between. The network does not know the cell-wise location, but a little larger, another level of location, area is created, and that is what we have been discussing today. In 2G, it was called location area or something. So in the case of say 2G, I'm talking about 2G because in 2G it is simpler. Later I'll move to 4G. So say location area is a it, uh, is a composition of a actually it is already written over there. Okay, can go back to our slide. Location area is something, it's a composition of a number of cells. And the network knows which location area the UV is in. The cell-wise location is not known, but the location area-wise location uh, is known. Okay, which location area it is in. So all the cells within the particular location area will broadcast a message that the network is looking for this particular UV when it wants to page. Okay, not the whole country. All base stations in the country will not be required to broadcast. Only the cells within a particular location, and the location area may have 20, 30, 40 cells. So these cells will, so uh, it's not too much. Now, the other problem that if you change your cell and update the network, then it will be too much on the radio resources, overhead on the radio resources. So here what is done, when you change your location area, then you update, only then you update. So every location area has an identity, location area code. Okay, and when the network EV finds that it has moved to a different location area, it communicates with the network. It and that procedure is called location area update procedure. Okay, um, so it works this way. As you the location area may have a number of cells. Okay, all these pink circles represent cells. So as you are moving, okay, from here to here, there will not be any update operation. You don't update the network. So you are moving this way, moving this way. Okay, you don't update the network. But as you move to this cell from here to here, your location area changes. Okay, and then you let the network know, which is called location area update operation. How you do that? Well, you perform this random access procedure. Random access procedure. Okay. And first send some bits to the network. The network then it really realizes that you want to communicate. So network asks what you want to do. Then you tell the network that I have now moved to this location area. Now the question is how the EV comes to know that it has moved to a different location. As I say that every location area has a location area code. So it finds that the location area code has changed. Maybe the location area code was here, location area LSC1, here it is LSC2, here it is LSC3. Okay. And these location area codes are broadcast on system information messages. System information message is something uh, which carry some common setup information from the network, and the network broadcasts them. Okay, we discussed DRX operation yesterday, and we know that in idle state, it wakes up once in a while. So what it does when it wakes up, it basically performs two things. Okay, whenever you turn on, okay, so uh, it does two things basically. Okay, during this period, it checks if the network is paging, okay, it checks paging, whether or not the network is paging. And the other thing is that it reads system information messages. And these system information messages in LTE, in 3G or 4G are sent in the form of some block. Okay, I mean some message packet, and so they are called SIB. It reads SIB messages. From now on, I will be using the term SIB, not the whole term system information block. Okay, and there are many different types of setting operation. Okay, so uh, there are also different SIB types. Okay, each SIB type includes a number of fields for different, and on these fields there are different parameters. Okay, so the network can set different parameter values on the SIB messages. I don't know how I can move to a new page here. New. Okay. Okay. So this way there are SIB type. These are called SIB type 1, SIB type 2. There are many different SIB types defined. You can find them on 36.331 because these are generated by the eNodeB. So, I mean, these are RC messages. The RC layer generates these messages. Uh, Many different, say, layer 2, layer 1 parameters are configured here. Like SIP type 2 is especially is a good set of parameter configuration. Many different layer 2 parameters are configured here. So if you just download the latest version of 36.331, you can uh, you can actually check how many SIP types you have now. When I was writing my book, there was up to SIP type 13. Okay, so it is just facilitated this way that in time new features will be added to the technology. So some new SIP types will also be introduced accordingly to set the required parameters for that new feature. Okay. So and these SIP messages are transmitted on and off, on and off. Okay. So it's not like that you always have to send this particular many. There are many different SIP types, and depending on your implementation, some SIP types will be there, some will not be there. So whatever SIP types you have, you just broadcast them depending on uh, how frequently you want them. All SIP types will not require the same uh, level of frequency. Okay, how quickly you want the SIP message repeated. Okay, depends on the feature implementation. Okay, but SIP type 1 and SIP type 2 are very important. Later, many different features have been added, and when I downloaded last this 3631, there was up to SIP type 24. Okay, so you can check the current number of SIP type if any further SIP types have been added or not. Okay, you can check that. Now, these SIB messages or paging messages, the phone reads in a way that they have, when it wakes up, we know that it reads PDCCH. This PDCCH includes some PDCC packets or instances, which had some PDCCH, uh, every PDCC instance uh, has its CRC scrambled by an identity. And we know that when resources are allocated, this identity is CRNT, okay, for uplink or downlink operation. In RC connected state, the UE has a identity CRNT, and that is used. Or if it is same persistent allocation, then SPS CRNT is used. However, when the network looks for someone, then uh, it uses a common identity. It has a fixed value. It's called PRNT. Actually, we have had that in the list of the discussion on uh, PDCCH, or when we are discussing data transfer. Okay, and when the network is sending some system information, it uses a fixed uh, value, which is called SIRNT, system information range. They have fixed values. Okay. In my book, I also mentioned actually what those values are. Or for CRNT also, there is a range of values. Within that range, you have to pick one. Anyway, so when the phone finds that the CRC is scrambled by PRNT, then it knows that, well, some paging message has been transmitted. And that PDCC instance also indicates the location of the paging message, the resource block location. So the UE can then read the resource block and read the paging message. And that paging message uh, indicates which UEs it is looking for. Okay, shortly, actually, after this part, we have the discussion on paging message, paging operation. And then you'll say that the paging message includes the identity of the users, which the UE is looking for. Okay. So all the users, it may be looking for just two users uh, from everybody in the cell. But all the users who are then awake, okay, will be able to read this PDC's instance, and they all know that, okay, there's a PDNT, so they all will read the paging message. And after them, there's just the two users find that this paging message uh, is for us or for ourselves only. The paging message will include the identity of those two users only. Okay, and that identity is STMC. Includes the STMC of the two users. Okay. On the other hand, if the CRC is scrambled by SIDNT, then uh, it indicates that a system information, some seed type, has been transmitted. And this PDC instance also indicates the RB locations of the seed type. So in this case, all users, okay, whoever is awake at that period, will have to read the system information message. Okay, it will read the resource blocks and uh, find out what the network is saying on the seed types. Now, this so when the U wakes up, the UE reads system information. So these are the two things. Uh, the UE, as I was writing before, the UE reads paging message, and the UE reads system information. These two things it does when it wakes up. These are the basic two. Okay. One of these SIP type, actually SIP type 1 includes the area's location. Well, in we are discussing 2G or 3G. So actually there also the SIP type 1, okay, includes the uh, location area code. Okay, in that case, in 2G it was called SI, not SID. From 3G, the term SID has started. They called SI message. But anyway, uh, the one of the system information message includes the location area code. So when the UE moves to a different location area and it finds, uh, I mean, it wakes up and reads the system information message, and then it finds that the location area code has changed. Now we have a new location area code. Then it identifies that it has changed the location area. Then the UE will initiate the location area update operation. Okay, and there will be exchange of a few messages, uh, layer 3 messages, RC level messages. So the network then is updated with the location area of the UV, but it is not cell level location. It is location area level location. The same operation is also done in the case of 2G or 3G when there is a change of routing area. Routing areas, I mean, in in the routing area and location area can be of the same size or they can differ. And in 3G also there is a third type of location area. But anyway, this particular slide I'm not including in the syllabus because it discusses 3G. Okay, in 4G we don't have CS and PS operation, so there's just one type of area. In 2G or 3G there are location area, routing area. In 3G there are also a third type of area, but in 4G there is just one type of area, track, which is called tracking area. Okay. But the purpose is basically the same. You cover a number of complete cells. Okay. And also there is a tracking area code, TSC, and tracking area update operation or TAU operation is performed, okay, when it is necessary. But there is also something called tracking area identity, okay, uh, which is actually this TI was also, I mean, these things was also there before, which is a combination of TSC, MNC, and MCC. Okay, so I mean, then you have a globally unique identity, and that identity is broadcast on SIP type 1. So the E is always aware of its current tracking area. Okay, it knows which tracking area it is in. And this one I have already explained that you have. Okay, now in the case of 2G, 3G, the addition is the concept of TAI list. Give me a second. Why it's not moving? Okay, here I mean the pages are actually done under the control of MME from the core network. The core network comes to know that there is, I mean, a data session should be initiated or something. So it asks the eNode B to perform paging. Okay, but actually the page messages are from the MME. Now, uh, in 4G, a TAI list is created which includes a number of TAIs. Okay, so a number of tracking areas are so another level of grouping. You create a new group which is uh, which is composed of a number of tracking areas, and the TAIs of all these cells are included in a list called TAI list. Okay, the EV is required to there can be 1 to 16 tracking areas in a list. Now the EV is required to change the is required to update when it finds that the TAI list is there is a change in the TAI list. Okay, the TI list is also broadcast on SIB, and when it finds that I have a TAI, now I have entered a TAI, a tracking area, which is not what which is not included in the TAI list that I had before. Okay, it was in a tracking area before, in a group of tracking areas indicated by a TI list. So it was also receiving a TAI list from the on the SIB. But when it moves to a tracking area, a cell which has a tracking area different, which has a tracking area, it finds that the TAI have now in this cell and is different from whatever TAIs I had in the last TI list, in the TI list that I read last. So then the EV is required to perform the tracking area update operation. Okay. So when the EV moves out of an area pertaining to a TI list and enters a new one, it updates. Okay. So using tracking area procedure, so the MME comes to know it has changed. Which it last register, as I was saying, that it last register, whatever TI list it has received last. Okay. Okay, this one is just a discussion on the trade-off that if you have, uh, this trade-off you also had for location area. Okay, like we can talk about the location area code that if you have a smaller uh, number of cells in a location area, then uh, then the number of location area update procedure will be higher. And if you have uh, a large number of cells in a location area, then you know that when it is the time for paging, all the cells will have to page. So more radio resources will be consumed then. Okay, so there is a trade-off. So such trade-off is also there in the case. Now, there is again something called MME pool area. We know that there are MMEs in the core network, and a number of MMEs can be connected optionally, can be connected to form a pool area. These are called an MME pool. Okay, MME pool or MME pool area. The area served under the MME pool is called MME pool area or MME area. Now, in fact, this MME pool area and the area covered by TI list are the same. There is one-to-one mapping between them. So basically, when you move out of a MME pool area, then you also find that the tracking area has been different. Okay, and when you are within an MME pool area, then you don't change your MME. You first, maybe you have first powered up, and the MME closest to you started taking care of you, start serving you. Okay, so you are connected to that. The you communicate with this. I mean, at the core network level, you communicate to this MME, and as you are moving to different places, as long as you are under the same MME pool area. Okay, remember that MME pool means a mesh connection among a number of MMEs. So the same MME can still take care of you because there is a connection. I mean, you may be under an E node B, which has a direct link to another MME, but that MME is connected to the MME which started serving you. So the same MME will keep serving you. Okay. So, and as long as you are within the same MME pool area. So the serving MME uh, uh, is not changed. The same MME usually maintains. Okay. It reserves some information of yourselves of the user, and it uses that for the purpose of different things. Okay. So as I was saying that when you move to a different, uh, when you go out of this MME pool area, then the same serving MME can no longer serve you, right? And this MME pool area coincides with the area of the TI list. Okay, so then you trigger a TAI procedure, and so the TI procedure also changes the serving MME. Okay, a new MME then starts taking care of you. Okay, now this type of management, it is a little different, but it's smarter compared to the older technologies. Uh, and one of the stark advantage with that, so TI procedure actually uh, changes your serving MME. So in this case, the advantages are, so the load sharing can be more balanced among the MMEs. The MME also has certain capacity. Every MME has certain capacity. So if an MME tends to get overloaded, okay, it can transfer some of its user to another MME under the same MME pool. Okay. Also, if there is a failure in the connection, okay, so say an MME, uh, even if there is a shutdown of one MME, other MMEs can take care of users. Okay, or I mean, it is the connection with this MME uh, is not working, so other MMEs under the same pool will be able to take care of. Okay, another and you can of course with the growth of the users, the the growth of the demand, okay, network load, you can add more MMEs to the MME pool. Okay. Another advantage is an overlapping among pool areas. You can maintain and reduce the uh, number of tracking area procedure. Okay. Uh, but the overlapped areas must cover some complete tracking areas. Okay. Let us go back to our uh, writing pad. Uh, this may be one tracking, on MME pool area. Okay, so indicated by a tracking area list. Okay, so a person here, when he powers up phone, he finds a tracking area list, and that tracking area list includes all the TIs here. But there is another tracking area, MME pool area this way, and there is a third MME pool area this way. So there is a overlapped region here, which includes some complete tracking areas. Now, within MME pool, you have some overlapping. Now, this area may be the downtown. Okay, actually, the downtown area. This is the downtown, and these are the residential areas, some satellite cities or different. Uh, you know, uh, the in downtown area, very few people live in. Okay, the rents are also high. So the further you go, the rents will be lower. Uh, so most people live pretty far, okay, and they come here for work. Now you see, so from all this located, so if we consider three residential areas, so all these people are coming in here, but there is no requirement of change of tracking area or tracking area update procedure, which consumes radio resources. And people who come from here also don't require any the triggering of tracking area. From here, okay, whoever comes in from here also don't trigger any tracking area update. Okay, because the downtown area, area where people uh, come to work, has been made common among all the people around. Okay, so this type of advantages are possible with the implementation technique in 4G. In 2G or 3G, this type of overlapping is not allowed. Location areas cannot overlap among themselves. Okay. Actually, there is no concept of TAI list there. Okay. Here you have a TAI list. Okay. On top of TAI or tracking areas, you also have a group of tracking areas. Okay. That pretty much completes our discussion on tracking areas, uh, and which addresses a part of paging. Uh, so it's just the central busy part of downtown shared by different pool areas. Okay, so this is probably the last slide, and we have finished discussing it. Now we will discuss paging operation. Give me a second. By the way, I have finished grading class both of your class tests, and I I'll publish the grade right after this class. Uh, but let me tell you, let me discuss the solution of the second class test. Okay, give me a second. Find it out. Sorry, give me a second, please. I have to. Okay. Justify the requirement of the two steps in the downlink synchronization process. Okay. Your answers were not exactly correct. Okay. I have I was liberal, and there has been good partial grading. But the actual point is the saving in correlation process. Okay. Most of you answered this way, that you need to determine two different things. You have two purposes: alignment in time and detection of the cell identity, PCI. So that is why you need two steps. Well, in fact, both steps has some action towards that purpose, some progress towards that purpose. In both steps, when you use the step with PSS or with SSS, you actually say, if we talk about PCI, we first find out the cell identity in a group. In the second step, we find out the group. Okay. The actual point is, in 3G, you needed three steps. Okay. Again, for this same kind of saving in correlation. Since we need a large number of variants, various PCIs, say around 500. If you want to find out from this large pool, from around 500 different options, there will be too much correlation. You have to perform correlation for every operation, for every option, until you hit the correct one. Okay, so the maximum number can be around 500. If you are lucky, then in the second hit you can be successful, but you never know. It can be even the last one. So this is why in two steps you can reduce. Okay, the search space was reduced from 512 to 8, like in 3G. Okay, so if you do it in multiple steps, then you can reduce the search space. Here also you reduce the search space first. Actually, PSS detection, you know the cell identity within the group. Then you have reduced the search space from 512 to 168. Okay. So you there is I mean one point. Okay. Secondly, if you have this, when you have this large number of options, around 500. Okay, so let us 504. So if you do it in one step, then on every symbol you have to check for all these 504 options. Okay, again, all these 504 options, all these five, and uh, in multiple steps, you can again uh, split. Okay, in time also you see that in, in half a radio frame, you hit your PSS. Okay, you check with first the early stage has a uses only a few different options, because in the first step you don't know the location. In every symbol you have to perform correlation. You don't know where to perform the correlation in the first case. Okay, so in the first step you allow only a few options, a very few number of options. So like here only three. And note that in 3G for primary SCH, the code is known. Okay, you don't have to find out from many different options. The primary SCH uses the same code everywhere in the world. Okay, you just check whether it is matching or not. So here you check whether it is matching from one of the three. Okay, so you perform three correlation operations for. So since you don't know the location, you have to have the number of options very small, and that is possible when you split into multiple steps. Okay, so in every symbol you can do that. So once you find out PSS, you know then the location of SSS. There you can work for little larger uh, options. Okay, 168 options that you can work with them, because you know where to perform that correlation operation. It's not too much. It's not too burdensome for you. Okay, so that's. But anyway, the uh, I just I mean wanted to make it a little thoughtful. Okay. Uh, no, but in terms of grades, you haven't lost. You'll see the grades shortly, and you'll see most of you are given 80%. Okay, 80% grades. Okay. When you, I mean, uh, say that you need to find out these two things. These are the two purposes. Okay, you got 80%. And the second question, almost all of you could answer correctly when you determine, okay, that whether it is FDD or TDD. But again, in the third question, you only a few could answer correctly. Uh, you had to calculate. You were supposed to calculate the number of resource blocks in one whole radio frame. In one radio frame, you have 10 subframes, and a resource block occupies half a subframe, just one slot, right? So in time span, in one radio frame, 20 resource blocks can be occupied, right? I mean, there can 20 resource blocks can be mapped to one whole radio frame, 10 milliseconds, because 0.5 millisecond or one slot is the length of time for a resource block. Okay. So there, the multiplying factor has to be 20. In frequency range for 20 megahertz, the question was like you uh, perform aggregation with three 20 megahertz bands, okay, and then determine the number of each 20 megahertz bandwidth support 100 resource blocks. We actually tabulated this value, and also you know that the number of subcarriers are 1200. So you have 100 resource blocks available. Okay. So 100 times 20, okay, and then you multiply by 3 because you are aggregating 3 of such bands. Okay. So 100 into 3, 300, and then you multiply by 20. So the answer is 6,000. Okay. Some of you could answer correctly, but no, most of you couldn't. But again, the partial grading was not bad. Okay. Uh,
Sir, have you finished checking all the scripts of the quiz, sir?
yeah, for both classes, I have finished, and right after this class, I'll publish the admission. The grades will be like before. The grades will be available in the Google Drive.
Sir, in before mid, we were supposed to give two quizzes, but one thing we have noticed that if we give quizzes, in that case our study goes well because without quizzes the pressure doesn't come.
Right.
So it would be better. So if we can give two quizzes before the final, sir, we don't want to
Definitely. I,
hold quizzes until the final, sir. After the final.
yeah, I was little late in starting our quizzes because with some early discussions, I mean, we have to settle with a few things first. Okay. But now we are up and running. So we can take class tests anytime. Anytime. Okay. And even for our second class test, actually, I was repeatedly um, saying that you might go for it earlier. Okay, that would help you uh, have a have an idea about the type of questions or take some preparation. Okay, but you were insisting on taking it after the on the day of the midterm, or okay, and even after the midterm exam. Uh, so do you remember? I was telling you repeatedly that you might take it earlier. That would be more beneficial for you. Anyway, so I think in the next week we can set a date for our third class test, and thereafter, I mean, uh, I mean, anytime soon we can also go for our last class test. Okay, our next discussion is. Give me a second. By the way, if you look at our data transfer, or when we discuss PDCCH, let me see. See, when we discuss PDCCH, I actually included all these options. Okay, CRNT, the CRC of the PDCC instance can be scrambled by different things, CRNT and PRNT, SRNT. We are yet to discuss this temporary CRNT or RNT. We'll discuss them when we explain random access operation. And MRNT, we will, that is used for MBMS operation, mobile TV. Okay, so we're skipping that part because that is less important. Okay, so the rest of the ranges we'll have to touch upon. You have been touching upon. Okay, then Okay. The paging operation, in general, is used for RC. Is I mean, most mostly it is used in RC idle state, but it can also be used in RC connected state. Okay. In 2G, there is no option like that, but in 3G also there is a paging in connected state. So in 4G it is there, and in these cases, it is used for say to inform about a system information change. I mean, the UE should read the system information. Okay. If some parameter values may have been changed and it may be something urgent. Okay, so it's notified. But normally you perform paging in RC idle state to inform the UE about some incoming call or some downlink data session needs to be initiated. Okay. Uh, there are also two things to take care of emergency situation: earthquake and tsunami warning system, and the other is commercial mobile alert. The first one, as the name suggests, uh, sends some notification to the EV when there is a since we have just 3 minutes. Okay, I'll just talk about this thing. That in the case of earthquake, there are three waves. Okay, the first wave comes a few minutes early, but it, it is very weak, and we don't recognize this first wave, the first blow. Okay, but we can use some sensors in the earth which can detect this first blow. Okay. And after a while, a second wave hits. This also most people cannot recognize. Okay, it is little stronger, but it is still uh, ahead of the actual wave. Okay, the actual blow. Then the final uh, wave comes in, which hit, and there can be collapse of buildings or something. That is the strongest one. So you really have some scope to detect that a earthquake is ahead. Okay, it is imminent. It's possible to detect using sensors in the ground. Okay, the first two waves are used, especially the first one can be used to inform people quite earlier. So as soon as the sensors detect, they are connected to the mobile core network, and the core network informs the EVs, okay, which the part of the EVs who are in the same location from from which the sensors have informed. And these notifications are not like what you set. Not a lot of times on your phone you cannot set the way it would react. Okay, there can be flashing on the phone and beep sounds, repeated beep sounds. Okay, with an emergency notification that and it will just uh, use a message that an earthquake is coming in or tsunami. Some information can be included there in the message. So this type of notifications are sent on SIP. This ETWS notification are is sent on SIP type 12. Okay, and as soon as the mobile receives, it uses the beep sound, the flashing, whatever it is supposed to do. And it does it whether you are in RC idle state or RC connected state. Okay, so in RC connected state, also the network can send the message. Okay. It is 11:45. So CMAS is something similar. Uh, uh, I mean, in the case of some kidnapping or some urgent notification from the government, CMAS can be used. Okay. But anyway, let us stop now here. I'll see you next week, and shortly I'll upload these slides. Any questions? Any questions on this
No,
part?
sir.
Okay. The last chapter of my book discusses this PTWS, CMAS. Okay, this type of operations are explained in the last chapter of my book, chapter 26. Okay, so thank you for your time.
Assalamu alaikum, sir.
Walaikum salam.